Welcome KSM Pharmatech YouTube channel is like. Welcome back to KSM Pharmatech. Today we will discuss about disintegration test apparatus definition, principle, uses, evolutions, guidelines and many more in details. Disintegration test definition. A disintegration test assesses how quickly a tablet or capsule breaks down into smaller particles when immersed in a liquid, simulating the conditions in the body. It is a crucial quality control test for solid oral dosage forms like tablets, capsules, granules, and pills. The test helps ensure that the drug is released from the dosage form and becomes available for absorption in the body within a specific time frame. Don't be confused on disintegration versus dissolution. Disintegration versus dissolution. Disintegration refers to the mechanical breakdown of the dosage form, while dissolution is the chemical process where the drug dissolves in the liquid. Disintegration is a precursor to dissolution. Disintegration apparatus. The test is performed using a basket rack assembly with tubes and wire mesh immersed in a liquid at a controlled temperature. Historical origins and evolution. Early quality control, pre-USP era, in the late 1800s pharmacists recognized that tablets must break apart in the stomach too slow, and the drug wouldn't absorb too fast, and it could irritate the gut. Early homemade tests involved dropping tablets in warm water and timing by eye. Standardization in pharmacopoeias, 1920s, 1930s, the United States Pharmacopoeia, USP, formally introduced a basket rack disintegration test, 6 tubes, 28 to 32 dips per minute, 37 degrees Celsius bath, to ensure reproducible, pharmacopoeial compliance. Mid-20th century. European, EP, and British, BP, pharmacopoeias harmonized around similar methods, cementing the basket rack as the global standard. Technological refinements, 1970s, 2000s, automated timers and counters, mechanical counters replaced manual stroke counts. Digital temperature and stroke control. Microprocessor-based units maintain 37 plus or minus 2 degrees Celsius and 30 plus or minus 2 CPM precisely. Single tube and multicell variants, to accommodate large tablets or suppositories, Type A, 6 tubes, and Type B, 3 tubes, larger diameter, racks emerged. Integrated data logging, modern instruments log temperature, stroke count, time to disintegrate and interface with limbs. 2. Underlying principle disintegration testing simulates the mechanical and fluid penetration forces a tablet or capsule encounters in the gastrointestinal tract. It measures the time required for a dosage form to break into granules small enough to pass through a defined mesh, 2 millimeters. 1. Immersion and agitation. Cylindrical glass tubes, 20 to 22 mm, hold individual units, suspended in a 1-liter test fluid, usually water or buffer, at 37 plus or minus 2 degrees Celsius. A wire mesh, aperture 1.8 to 2.2 mm, lines the bottom plate. The rack reciprocates at 28 to 32 cycles, min over 50 to 60 mm stroke, repeatedly submerging and withdrawing the tablets. 2. Fluid penetration and mechanical stress, wicking. Liquid enters pores by capillary action, weakening interparticle bonds. Swelling. Disintegrants swell, creating internal stress that fragments the matrix. Strain recovery. Compressed particles rebound upon wetting, accelerating breakup. 3. Endpoint determination. Complete disintegration. No residue on the mesh except soft masses or insoluble coatings. 4. Key components of a basket rack disintegration tester. Basket rack assembly, 2 perforated plates, 90 mm diameter, hold up to 6 tubes, 77.5 plus or minus 2.5 mm length. Lower plate lined with stainless steel mesh, 2.0 plus or minus 0.2 millimeters aperture. Reciprocating rods maintain 50 to 60 mm vertical stroke at 28 to 32 cycles per minute. Discs, optional, transparent plastic, 20.7 by 9.5 millimeters, pierced with 5 to millimeters holes, added atop powders or soft capsules to keep them submerged. Thermostatic bath maintains fluid at 37 plus or minus 2 degrees Celsius throughout testing. Control unit governs stroke rate, stroke length, and logs time and temperature. 4. Practical uses and regulatory importance. Times quality control. Batch-to-batch consistency ensures tablets capsules release API at intended rate. In-process check detects overly hard compacts or faulty coatings before coating drying. Formulation development. Disintegrant screening, comparing starch, cross-carmelose, sodium starch glycolate, etc. Coating optimization, ensuring enteric or sustained release coatings meet disintegration specs. Regulatory compliance and stability, pharmacopoeial acceptance, mandatory test under USP 701, EP 2.9.1, IP 2.5.1. Accelerated stability, monitoring disintegration changes under high temperature humidity. Here are the must-watch factors when setting up or running a disintegration tester. 1. Pharmacopoeial compliance. Verify apparatus meets USP 701, EP 2.9.1 or relevant monograph, specs for stroke rate, 28 to 32 cpm, stroke length, 50 to 60 mm, bath temp, 37 plus or minus 2 degrees Celsius, and mesh aperture, 1.8 to 2.2 mm. Ensure you are using the correct rack type, A versus B, and optional discs per your dosage form. 2. Temperature control and uniformity. Bath fluid must be plus or minus 2 degrees Celsius of 37 degrees Celsius throughout the test. Stirring or circulation in the water jacket to avoid hot or cool spots. Calibrate your thermometer RTD probe regularly. 3. Stroke rate and length accuracy. Calibrate and log actual strokes per minute. Mechanical drift can creep over time. Measure actual vertical travel. Undershoot weakens agitation. Overshoot may damage samples. 4. Basket rack and tube integrity. Inspect tubes and mesh for corrosion, warping or mesh tears. Confirm mesh aperture with a go-no-go gauge. Check that tubes sit squarely and don't wobble when reciprocating. 5. Disc selection and placement. Use the correct number type of plastic discs for soft gels or low-density powders. Position discs without tilting to avoid uneven fluid penetration. 6. Media preparation and pH. Prepare the right volume, usually 1 liter, of test fluid, water, buffer or biorelevant, at specified pH. Degas or filter if required. Air bubbles alter wicking. 7. Validation and qualification. Perform installation, IQ, operational, OQ, and performance, PQ, qualifications on new or relocated units. Requalify after any major repair or at defined intervals. 8. Data logging and endpoint determination. Use automated timers alarms where possible to reduce human error. Standardize the visual or video-aided endpoint check. No bits greater than 2 mm remain, only soft masses. 9. Maintenance and cleaning. Rinse all wetted parts after each run to prevent salt crusting or biofilm. Schedule routine lubrication of moving parts and check for motor wear. 10. Operator training and SOPs. Document step-by-step procedures for setup, run conditions, endpoint checks and cleaning. Train technicians on common pitfalls, example, air bubbles under meshes, misaligned tubes. Some important question and answers. Q. What temperature and stroke rate does the USB basket rack method specify for disintegration testing? Ans. Temperature and stroke rate 37 degrees Celsius plus or minus 2 degrees Celsius with a reciprocation rate of 28 to 32 cycles per minute, stroke length 50 to 60 mm. Q. Name the two main rack types, A and B, and tell me how they differ in tube count or diameter. Ans. Rack types A versus B. Type A, 6 tubes, 21.7 mm each. Type B, 3 tubes, larger, 37.7 mm each. Q. What's the purpose of those little plastic discs you sometimes drop on top of a powder blend sample? Ans. Purpose of the plastic discs: they keep lightweight or buoyant samples, example, powders, soft gels, fully submerged so they're uniformly wetted and agitated. Q. Describe the three physicochemical phenomena that drive a tablet to fall apart when immersed. Ans. Key disintegration mechanisms. Wicking test: fluid penetrates pores by capillarity, weakening bonds. Swelling: disintegrant particles imbibe fluid and expand, creating internal stresses. Strain recovery: compressed granules rebound on wetting, aiding fragmentation. Q. How do you know you've hit the endpoint in a disintegration test? Ans. Endpoint criterion: all sample residues have passed through the mesh to aperture, leaving only soft masses or insoluble coating fragments on the screen. Q. Why might you swap water for a biorelevant medium during R&D? Give one advantage. Ans. Why use a biorelevant medium? A simulated gastric intestinal fluid with relevant pH, enzymes, bile salts gives a closer prediction of in vivo disintegration and subsequent drug release. Q. Contrast disintegration testing with dissolution testing in one sentence. Ans. Disintegration versus dissolution. Disintegration tests how fast a dosage form breaks into granules. Dissolution measures the rate and extent of the API going into solution. List of dosage forms to which the disintegration test is applicable. 1. Uncoated tablets, immediate release tablets. 2. Hard gelatin capsules, similar to uncoated tablets. Hard gelatin capsules are expected to disintegrate and release their contents within a specified time. 3. Soft gelatin capsules. 4. Enteric coated tablets and capsules, delayed release. These require a two-stage disintegration test. Acidic stage, they are first tested in an acidic medium, simulated gastric fluid, for a specified period, example, 2 hours. During this stage, the enteric coating should remain intact, preventing disintegration in the stomach. Buffer stage, after the acidic stage, they are transferred to a neutral alkaline buffer, simulated intestinal fluid, where the enteric coating is expected to dissolve, and the tablet capsule disintegrates. 5. Film-coated tablets. 6. Dispersible tablets. 7. Effervescent tablets. 8. Orally disintegrating tablets, ODTs, mouth-dissolving tablets. Dosage forms where DT is generally not the primary test or not applicable. Extended release, sustained release tablets, capsules. These are designed to release the drug slowly over an extended period, not to disintegrate rapidly. For these, dissolution testing is the critical quality control test. Chewable tablets. These are designed to be chewed, not to disintegrate in a liquid medium without mechanical action. Parenteral preparations, injections. These are sterile solutions or suspensions and do not undergo disintegration. Topical preparations, creams, ointments, gels. These are applied externally and do not disintegrate internally. Liquid oral preparations, syrups, suspensions, solutions. These are already in liquid form. Powders and granules for oral suspension solution. While the individual particles might dissolve, the disintegration test as applied to solid compacts is not relevant. However, for granules intended to be dispersed, a similar concept of dispersion is evaluated. At KSM Pharmatech, we are committed to empowering pharmaceutical professionals with knowledge and the right tools. Understanding equipment like the DT apparatus is fundamental to ensuring your products meet the highest regulatory standards and, most importantly, deliver optimal therapeutic results for patients. If you found this video helpful, please give it a thumbs up, share it with your colleagues, and subscribe to the KSM Pharmatech channel for more insights into pharmaceutical technology, equipment, and best practices. Don't forget to hit that notification bell so you don't miss our upcoming videos.